Archaic humans might actually be the same species as us, study suggests. Our species is defined by a long list of cultural and genetic traits that set us apart from our ancient counterparts. New research suggests at least some key distinctions date back earlier than previously estimated, hinting that modern and archaic humans, including our close extinct relatives, have more in common than we ever thought. Our results point to a scenario where modern and archaic should be regarded as populations of otherwise common human species, which independently accumulated mutations and cultural innovations, writes a team of researchers led by biologist Luca Pagani of the University of Padova in Italy. In a study of critical rearrangements of our chromosomes and select variations in our genes, the team looked at genome databases built from Neanderthal fossils, Denisovans fossils, and modern human samples. One specific change they analyzed is the translocation of human PAR2, pseudo-autosomal region 2, a swapping of the tips of our X and Y chromosomes. This occurred relatively recently in primate evolution and effectively improved reproduction rates and genetic stability in males, pretty crucial for species that want to persist. Together with a major rearrangement that generated the human chromosome 2, changes to PAR2 are what separate humans from apes and chimpanzees. The last ancestor of today's Y chromosome can be traced back to a little over 300,000 years ago, long after our split from Neanderthals. Sometime prior to this last common ancestor's existence, the changes occurred in our PAR2 region that helped define a major milestone in modern human evolution. The question is, did it happen before or after humans and Neanderthals departed ways? The genome database information was mapped against three key events in our evolution. One, a population bottleneck event 900,000 years ago. Two, the separation that resulted in Netherlands, Neanderthals, Denisovans, and modern humans 650,000 years ago. And three, the reintroduction of Neanderthals to modern humans, combining genomes again 350,000 years ago. If we are searching for an instant that defines the human lineage, the study authors write, we can state that the events that made all of us humans are represented by chromosome 2 fission and PAR2 translocation. The team's analysis took into account mutations in the Y chromosomes PAR2 that were not present in the X, helping pin down further the timing of a common ancestor for the translocation event. Crucially, they found that PAR2 change happened way before event 2, when it's accepted that Neanderthals and humans diverged. It means critical genetic changes that define us as modern humans may go back further than we realized, putting together the various lines of genetic evidence accumulated so far. We can partition the derived features that occur in defining us as modern humans in a time and evolutionary informed way, write the researchers in their paper. In fact, the researchers say that PAR2 translocation probably occurred closer to event 1, a separate, severe population bottleneck for the ancient ancestors to both Homo sapiens and Neanderthals. That fits with another important shift in human evolution, the chromosome 2 fusion. In other words, genetic seeds of what makes us special as human beings stretch back closer to 1 million years ago. Since then, various periods of population growth and shrinkage, together with more cultural influences, have helped separate us from Neanderthals and Denisovans. The team identified functional variations in 56 genes between modern humans and our distant cousins emerging soon after event 2, mainly linked to brain and skull traits. During event 3, a period of Neanderthal and Homo sapiens interbreeding, most of these genetic traits were not passed back to the Neanderthals. That's perhaps due to population pressures or societal norms, the researchers suggest. It again raises the question of just how much sets us apart from the Neanderthals, a question that several studies have already asked. And while the researchers don't definitely answer the question, are nor explicitly seek to draw the line between different kinds of human species, the author suggests we have more in common with our archaic counterparts than we previously realized, to the point that such distinctions may need to be reevaluated. The study has yet to be peer-reviewed, but it's available on preprint server bioRxiv. This is by David Neal on Science Alert. Please leave your comments, and thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.